Let's go through some of the practice problems for basic for loops. So in lab this week, you were asked to load up the R programming practice, R data saved environment, and to work with some of the objects in here. And we'll be coming back to these in the next few weeks as well. The first question asks you to examine the product data frame from reg class, however. So let's go ahead and load up the library reg class and get the product data frame into the global environment. Now, specifically, what are we going to investigate? We're interested in investigating what proportion of products succeeded, or more specifically failed, for each of the different product categories. Category is a factor in this data frame containing 4 levels, A, B, C, and D, and we have some information about whether or not the product succeeded or failed. Now, it turns out that there's a very useful function in R called aggregate, which will very quickly allow us to calculate the proportion of failures for each one of these categories. Now, I've given you the aggregate function mostly so that we can check our work here, but we get an idea for which product categories are succeeding and which ones have not. Almost everything in category A fails, everything in category D, or half of the stuff fails, half the stuff succeeds. So we'd like to get some practice writing a for loop to essentially reproduce what the output of aggregate is. So how could we use a for loop to go through each level of category one by one and to calculate the proportion of failures for them? So that's our goal. We're writing a for loop, and we're going to store the proportion of failures in a vector called prob failure. So when we're sitting down to write a for loop, the worst thing that we can do is actually start out by trying to put in the skeleton of the for loop. We want to save this for last because a better recipe for success is to make sure that we can get our code working for a specific instance of what we're looping over. So before even writing any code, we need to think to ourselves, all right, well, what am I looping over in this case? And what's going to be the name of the variable that I give to the looping variable? In this case, I'm going to be looping over the levels of the category column because I want to do something for each one of those levels. I want to calculate the proportion of failures for A, for B, for C, and for D. So the vector of values that I'm going to be looping over are the contents of the levels vector of the category column, and I just need to come up with a name for the looping variable. When I get my code working for the specific instance, it's best not to hard code any numbers or any values that are specific to that instance. Instead, we want to keep the code as general as possible. So in this case, what I'm going to do is I'm going to create my looping variable, and I'm going to call this category. We're looping over categories, so it's a smart name. And I'm going to try to get the code working for category C right off the bat. Now, there's a bunch of tips down here that you can follow that's supposed to point you in the right direction, but very often when I sit down to solve a problem, I might approach it in a slightly different way. So this might deviate a little bit from the tips, but we'll just go with that. All right, so I'm going to left arrow category to be the word C to represent the fact that we're going to be trying to get some code working for product category C here. Now, what do I need to do? Well, I need to take a subset of the rows in the product data frame that correspond to product category C, because I want to calculate the proportion of failures for category C here. So how do I get a subset? Well, I'm going to want to create a subset, so I'm going to create a name for that subset just called sub in all caps, and I'm going to left arrow into that the result of running the subset command. So I want a subset of product where the entries in the category column are equal to category C. So how do I set this up? Well, the first argument is product here, the name of the data frame that I'm taking a subset of. And then after the comma, I'm going to put in the condition on rows that I want to be selecting. So in this case, I want to be selecting rows where the entry in the category column is equal to C. So I'm going to say category double equals because I'm checking to see if something is or isn't a value. The single equals actually sets equality, just like the left-hand arrow symbol. And because I want to keep my code as general as possible, I'm not going to type in double equals C in quotes. And that's because I've stored C as just the placeholder category, my looping variable. And so I'm just going to go ahead and copy and paste the name category here. Category is understood by R to equal C at this point, and so I'm taking a subset of products that are just category C. Now I can make sure that this subset took by looking at a summary and confirming that indeed I only see values for product C here. So I see a bunch of failures and a bunch of successes, and I can, by hand, calculate what the proportion of failures are. So a total of 504 failures out of a total of 504 plus 162 successes. That's a proportion of just under 76%. So how can I get this number out automatically? I need to write a piece of code to produce that number. Now, one of my favorite tricks for calculating the proportion of elements that equal a particular number or that are greater than a certain number is to take the average of a logical condition. So what do I mean by that? Well, I'm going to type in the function mean. I'm going to be taking an average. And what I'm going to type in is sub $outcome. So if I just look to see what is sub $outcome, that gives me all of the entries in the column, a bunch of successes, a bunch of failures. If I want the proportion that are equal to fail, well, I can separate fail in quotes from sub $outcome with a pair of equal signs. This is a logical condition that will return true when the entry and outcome is fail, and false when the entry and outcome is success. So if I run this, I get a whole bunch of trues and falses. And the nice thing about R is that true is the number 1, false is the number 0. So by taking the average value of this vector, I get the proportion of trues, or in other words, the proportion of products that have failed. So in this case, I find that it indeed works out to be that number, a little bit less than 76%. So what do I want to do with that number? Right now, running this command, it gets shot out to the screen and then it disappears. I need to be storing this into the vector that I'm creating to keep track of the probability of failures. And so now here's a time to go and initialize this variable to be the empty vector, a null vector, nothing in the middle. We'll fill that in as we work our way through the for loop. But basically what I want to do is to left arrow into prob failure the result of running this command. So this is my 76%. I don't want to left arrow it into the entirety of prob failure though, only a very particular element. What element do I want to be defining? Well, in this case I was going through specifically for product category C. I can turn on the square brackets and actually just type in category here, and let's see what R comes up with when I do this. So initialize it, put into the category position. Even though category is a word, it's not a number, this is still going to work. And what R does is it actually creates a vector. The first element right now is that number, and what you'll notice that it's given that number a name. So whenever you turn on square brackets to actually put in a word inside the square brackets instead of an integer, what it will do is it'll look for an element with the name that was inside square brackets and change that value to whatever number emerges on the right-hand side of the left arrow. If that name doesn't exist yet, like if I start out with prob failure here, there's nothing in there. If I refer to the position by name and it doesn't find that name, it'll just append as the very last element to that vector, element with that name. So by saying product failure bracket category, there's nothing in there, it doesn't find that name, so it appends to the end of that vector, currently empty, so in effect it's creating that first element. We get out what our intent is. Okay, so the code's working for this specific instance. Now we are ready to set up the for loop. So I'm going to put some spaces in between the curly brackets because that's where all the lines of code are going to go. Let's set up what goes inside the parentheses first. What do I need to put to the left-hand side of the in, and what do I put to the right-hand side of the in? Well, to the left of the in is the name of my looping variable, and I've set up my specific instance so that the looping variable is called category. So I've chosen that ahead of time. It's up to me. I'm calling it category. On the right-hand side of the in are the vector of values that I want to be looping over, the values that I want category to take. Now, I want to loop through category A, B, C, and D. I want to be looping through the levels of the product $ category column. And so here's how I'll set up my for loop. If I highlight what's to the right-hand side of the in and print the contents of that vector to the screen, I can confirm that here's what I'm going to be looping over. And category is going to be the name of my looping variable. So inside the square brackets, well, I'm going to just copy and paste the code that I've already written and confirm that it works. And I'm going to highlight and then re-indent just to satisfy my desire for neatness. All right, so what is the code going to do? Well, as R runs into the for loop, it's going to check the parentheses. and it's going to left arrow the object to the left-hand side of the in category to the first element of the vector to the right-hand side of the in the first time through the loop. So category will be left arrowed to the word A, and then the code inside the curly brackets will run. So we'll take a subset of product where the entries in the category column are the current value of category, which is A, and then it's going to define the A element of prob failure to be the proportion of elements in that outcome, that subset, that are equal to fail. And we go back, the category gets left arrowed to be the second element of the levels command, so it becomes B, etc. So I'm going to make sure to have this reinitialized right before this for loop so I can put stuff in it. I'll run it, and now I'll glimpse to see, well, what are the entries? And so I see I get a named vector that emerges. Since we loop through categories A, B, C, and D in order, we see that we have elements named A, B, C, and D in order, and we have the proportions for each one of them. So we achieve the same thing as running the aggregate command. We get the proportion of failures for each category. For question number 5, we're going to do a bit of hacking. So in question number 5, we're going to refer to a function in the global environment called crack. And the deal with crack is it's a function where we get to pass a single number to it, and we're either going to get back false if that's not the secret code, or true if it is the secret code. So these 4 examples all return false because none of these 4 numbers are the secret code. Our job is to hack the secret code basically by going through every possible value and determining which one works. So 1, 100, 340, this other number, not the right one. How can we write a loop to go through every possible code and determine which one is the secret code? Which value is going to make crack of that value return true? Now we can write a while loop or a for loop to accomplish this task, but since we haven't quite talked about while loops yet, let's do this in the context of a for loop. So once again, before we actually sit down and write the for loop, we want to make sure that we get the code working for a specific instance. So what are we going to be looping over? We need to come up with the looping vector, the vector of values that we're going to be looping over. And in this case, it's just going to be the integers 1, 2, 3, 4, all the way up to 99999. The secret code is an integer somewhere in this range here. So that's going to be our looping vector. And we're going to get a code working for a very particular instance of that looping vector. Let's choose arbitrarily 4478 to be the code that we're going to try out, and we'll make sure we can get our code working for this. So I'm going to left arrow this into a variable called attempt, and I'm going to just look forward and actually say, let's have attempt be the name of our looping variable. So I'm going to left arrow attempt into, or 4478 into attempt, and I can try this out. Maybe I came up with a lucky guess. What's crack of attempt? Oh, it's false. Okay, so what do I need to do here? Well, one way of approaching this is to create a vector and to store into the elements of that vector the result of running crack on the relevant position. So the first element of this vector would contain the true or false that emerges from running crack on the number 1. The second element, the result of running crack on the number 2. Third element, crack on the result of running 3. So how can we go ahead and do this? Well, let's create a vector called outcome. We'll initialize this here. And we'll use that for loop to go through the first element, second element, third element, etc., and to store the result of running crack on that position. So the 5,000th element of outcome will be the result of running crack on the number 5,000. The 400,478th element will be the result of running crack on the number 4478. So how can I do that? Well, since we're working with 4478 right here, I could say the 4478 element of outcome is going to be crack on the number 4478. So once I've initialized it, I run this, I can glimpse to see what are the contents of outcome. I get a whole bunch of NAs, and in fact R only lets me print out a total of 1,000 entries. But if I look at 4478, I see a false there. And I can look a few before, a few after. We get our false in that particular position. Now, they're all NAs because I actually haven't done anything to define what the value should be there. That's what my for loop is going to do for me. But the key thing is that, okay, I got a little bit of the code working at least. I'm putting into the position 4478 the result of running crack on 4478. Now, when I'm writing my code to get it working for the specific instance, I want to make sure to keep that code as general as possible. So instead of hard coding 4478, this number that I'm trying, since I left arrowed 4478 in there, I'm going to replace this to keep the code general. So now outcome attempt is going to be the 4478th element of outcome, and crack attempt will be the result of running crack on the number 4478. So if I reinitialize it, kind of wipe everything out, there's nothing in there. Define outcome bracket attempt, I see that we've defined that one particular element to be false. So okay, now what do I need to do? I need to loop through 1, 2, 3, 4, 5, 6, all the way up to 99999 and define the corresponding position of the outcome vector, the result of running crack. So in order to make my for loop go, I need to say what's going to be on the left-hand side and the right-hand side of the in, and then say, all right, what's the code inside the curly brackets? Well, I've already written the code that's going to go inside the curly brackets, so let's just borrow that. I just need to make sure to specify the parentheses correctly. So to the left-hand side of the in is the name of my looping variable, and when I was writing my specific case, I just used the variable name attempt. So we'll reuse that as the name of the looping variable. And what are we looping over? Well, we need to loop over 1, 2, 3, 4, all the way up to 99999. Here's our shortcut for the integer sequence, 1 up to 99999. So how is R going to attempt to run this code? Well, let's make sure to initialize outcome right before it. Well, as R runs into the for loop, attempt gets left arrowed to be the first element of the looping vector. So attempt becomes equal to 1, and we run the code inside the curly brackets. We place into the first element of outcome the result of running crack on the number 1. We go back to the beginning. Attempt gets left arrowed to be the second element in this vector. It's number 2. We put into the second element of outcome the result of running crack on the number 2. All right, great. So we've gone through all 99,999 integers here, tried them all out. Exactly one of these integers is going to result in having crack of that integer equal to true. So I need to ask, okay, well, which one was it? Well, that word which kind of crept in, and that suggests what the name of the command I want to use. I can ask which position of the outcome vector is true. So the which command says, all right, I'm going to dive inside this vector. I'm going to check out each element, and I'll identify the positions where I find this logical condition to be true here. So which positions of outcome have true in them? If I look at the first 100, I see a whole bunch of falses. So which position has a true? Running this, I get 59148. I can confirm that it is indeed true by just referencing that position. It looks like I've cracked the secret code, and in fact, if I run crack on this integer, I find that it's equal to true. All right, question number 8 is asking us to write a for loop to define the elements of a vector called running average. Now, what is running average supposed to contain? Well, it's going to contain the running average of the elements of the acquisition cost vector, something that should appear after you load in that R data file. The acquisition cost is the effective amount of money that it took to acquire each customer in this data set here. So what exactly do I want? Well, let's just do some exploration. Let me look at the first 5 elements of acquisition cost. So here are the acquisition costs of the first 5 vectors. What I want to do is I want to put into elements of running.average the average of the values up to some point. So for instance, I want the 5th element of running average to be the average of the first 5 elements of acquisition cost. I want the 57th element of running average to be the average of the first 57 elements of acquisition cost. Okay, not too hard to describe that in words, but let's get some code working to do this automatically for us. We don't want to run 500 different lines of code to define each element one by one. All right, so before even doing anything with the for loop, we're going to get our code working for a specific instance. And before we start to do that, we want to think about, well, what are we looping over and what do we want the name of our looping variable to be? Well, in this case, what we're going to be doing is we're going to be looping through positions in the acquisition cost vector. We're going to be doing something for each position. So for the 5th position in acquisition cost, we're calculating the running average, or just the average of the first 5 elements, and putting that into the 5th element of running average. So because we're looping over elements, why don't I call my looping variable element? And let's choose 5. We'll get our code working for the number 5. So what I want to do is I want to look at the first 5 elements of acquisition cost. But because I want to keep my code as general as possible, I don't want to hard code any numbers that are specific to this example. Instead, I want to use names of variables that I've created. I'm going to have my looping variable be called element. I've made element equal to 5. So 1:element will print out the first 5 elements of acquisition cost to the screen here. Now, how do I get the average of just these 5 values? Well, the mean command is there. All right, so the running average, at least the 5th element of running average, should be this value. So how can I get this value into the 5th element of running average? Well, I can say running average bracket element, left arrow this. Now if I run this as is, it's going to fail. It's going to say, hey, I don't know anything about running average. That's because if I'm going to use square brackets to put in a particular element of a vector, R needs to be aware that that vector exists somewhere in the global environment. So I actually need to initialize running average to be something. Doesn't matter what I initialize it to. Right now it's an empty vector. That'll allow me to put into the 5th position, or the element position, the relevant number. So the first 4 elements are NAs. I haven't defined those yet. The 5th element is 526.01. All right, so that's basically the brunt of all the code that I need to write here. Basically what I want to do now is run this when element is equal to 1. Element is equal to 2, 3, 4, 5, all the way out to 500, so that I'm defining each element of running average appropriately. The average of the first element numbers of the acquisition cost vector. So the 460th element of running average, running.average, should be the average of the first 460 elements of acquisition cost. All right, so I'm just going to borrow that code that we wrote and then set up the rest of the for loop. To the left of the n is the name of my looping variable. I've already chosen that to be element here when I was writing out that specific case. To the right-hand side of n needs to be the vector of values that I want my looping variable to take. Well, we've already discussed this. We want element to be equal to 1, then 2, then 3, then 4, all the way up to the number of elements in acquisition cost. So we can put in the shortcut for that integer sequence as 1:length acquisition costs. Now I know that acquisition cost has 500 elements in it, so I could do 1:500, but to keep the code as general as possible, what if we added more customers into this data here? Length acquisition cost is always going to extract out the right number of elements for me. So here's my vector of values. I'll run that as a command just to confirm that it's containing all the values that I want element to be. And so what is R going to do when it runs into this code? Well, it sees the 4, it jumps into the parentheses, and looks at the n. So what it's going to do the first time through the loop is it's going to left arrow the name of the looping variable to the left of the n, element in this case to be the very first element of the vector to the right of the n. So element gets left arrowed to 1. We run the code inside the curly brackets, so we see we're defining the first element of running average to be the average of the elements 1:1, that's just 1, the average of the first element of acquisition cost. Run out of code, element now gets left arrowed to be the second element of the vector to the right of the n, and we're defining the second element, second position of running average to be the average of the 1:element, 1:2, first 2 elements of acquisition cost. Looks good. I just want to make sure to have that initialization right before for loop runs. Fix up some spacing, and we'll run this. All right, we'll look at the first few elements of running average. Here are the numbers that emerge. And in this case, I give a sanity check that says the 278th element should equal this particular value, so we can double check our code. We want it to be 497.9211 or 121, and we got that. All right, so it looks like we've calculated the running average. We've essentially written a shortcut that does 500 lines of code behind the scenes, all really quite quickly for us. All right, the last question in the activity asks us to basically evolve the amount of money in a savings account. And the evolution is going to take place with a pretty predictable pattern. So what we have is that at the beginning of month 1, the balance of this account is 100, and at the end of month 1, interest is going to be accrued. And what we're going to say is that every month it's going to accrue 2% interest on what's in the account at the end of the month. So in this case, 2% of 100 is just 2. So at the beginning of month 2, we have $102. Now what's going to happen from here on out is that a deposit of $10 is going to happen mid-month. So this 102 that exists at the beginning of month 2 is going to become 212 by the end of month 2, because the deposit happens mid-month. So at the end of the month, there's $112 in it. It's going to earn 2% interest. 2% of 112 works out to be $2.24. And so the beginning of month 3 is going to have a total of $114.24 in it. The end of month 2 plus the interest that was gained. And now a deposit of 10 is going to happen mid-month. The balance bumps up to 10 more, so 124.24. And then at the end of the month, interest is accrued once again. So 2% of 124.24. Well, in this case, it doesn't work out to be a cent. It's a fraction of a cent here. And so this bank's policy is to actually just round to the nearest cent. Sometimes it rounds up, sometimes it rounds down. So we see that in this case, it's going to round down to 2.48. And so the end of the interest will be that value. And the beginning of the month's 4 balance is going to be 126.72. Now, let me just reconfirm that because that seems a little fishy. That was the interest. We're rounding it to 2 digits. And then we're adding that to what the balance was, which is 124.24, 126.72. So yeah, that looks good. I just got to make sure to update these numbers here. That interest was 2.48. All right, we're happy. All right, so this keeps going. Keeps going, 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 and going. What's going to happen to the balance of this bank account as we just continue this investment strategy? All right, well, that's going to be a job for a for loop. We could go through and reason through, one by one what happens month 4, 5, 6, 7, 8, all the way out to the end of time if we wanted to. But this is a job for a for loop. The bank account balance is evolving very predictably, so we'll write a for loop that automatically figures out what these balances are going to be. So what we're going to do is we're going to define a vector called balance to store the beginning of month balances. So it starts out at 100, it goes to 102, and then it goes to 114.24. We've already reasoned through what the beginning balances are for those first 3 months. And let's go ahead and try to figure out how we can write a for loop that will go through and one by one define the 4th element, the 5th element, the 6th element, etc., to represent how much money is in this account at the beginning of each one of these months. So before even diving in and writing our for loop, we want to make sure to get our code working for a very particular instance. So in this case, well, why don't we get the code working for the 4th month? But we're not going to hard code 4 in our code because we want to write it general. We're going to come up with the name of a looping variable, and we'll write our code in terms of that looping variable. So what we can do is we can come up with the name of a looping variable. Let's call it m, lowercase m, maybe short for month. And we're going to try to figure out what the balance at the beginning of month 4 is going to be in terms of the previous balances. All right, so how is this going to work? Well, I'm going to be putting into the m position of balance here. M is currently 4. Some value. What is that value going to be? Well, let's think about it. So it's going to be equal to the balance at the beginning of the previous month, the balance that existed at the beginning of month 3, plus that $10 deposit, then plus the interest that was earned on the total amount of money that existed at the end of the month there. Now the total amount of money that existed at the end of the month is the beginning plus that 10, and so the interest is times 0.02, 2% here. So since m is 4, we can actually just highlight some of these things and confirm that, all right, we're doing the right thing. So let me initialize balance to contain these three values. The beginning balance in month 3 is 114.24. We add 10 to it, and then we add the interest. So the interest is 2% of what exists at the end of the month. So the interest is this quantity. However, we need to make sure to round that interest. So we'll round that amount to 2 digits. So we're really only adding this much. So the beginning balance in month 4 is that 126.72. All right, so it looks like we've developed an equation that tells us what the balance in position m is going to be if we know the balance in position m minus 1. So we're ready to basically do our for loop. So I'm going to reinitialize balance to be these three values right at the beginning. And I need to determine, all right, so what goes to the left and to the right-hand side of the n? Well, to the left is the name of our looping variable. And since we wrote our code in terms of m being equal to 4, let's reuse m as the name of our looping variable. What values do we want m to take throughout the loop? Well, we already have the first 3 elements of balance, so we should start out with element 4, then move on to element 5, element 6, element 7, and we want to go all the way out to month 480 here. So we can write that integer sequence 4 to 480 with our shortcut. 4:480 gives us that integer sequence. So, all right, we can just borrow the code that we got working for a specific case when m was equal to 4 and put it inside that for loop. So what's going to happen? Well, we initialize balance to have those 3 values. We dive into the for loop. M gets left arrowed to be the first element of the looping vector. So m becomes the number 4. And we see that we define the 4th element to be the 3rd element plus that mid-month deposit plus the interest earned on that, rounded to 2 digits. And we run out of code. M becomes left arrow to 5. And we define the 5th element of balance to be the 4th element plus that mid-month deposit plus the interest that's earned, etc. So we can evolve that bank balance, print out the contents. We can kind of see that, wow, these numbers start to get big pretty fast, actually. And now we can answer some of these interesting questions. So number 1, we can do that sanity check. We want to verify that the first 8 elements of balance are that 100, 102, 114.24, 126.72. It looks like it's matching up. So no issues in the code. And now what we're going to do is find the elements in positions 104, 100 to 104. So 100 to 104. After 100 months, well, or the beginning balance in month 100 is a little over $3,700. And we see that it's going up and up and up. We deposit $10 each month, get some interest. It's going up pretty big. So what's the first month that has at least $100,000? So how long does it take us with this investment strategy to have $100,000 in our bank account? So the question that we're asking is basically which position in balance has numbers that it's at least 100,000, and what's the smallest one of those? Well, if we ask which balance is at least 100,000, that'll dive through the elements of the vector balance and report back where it finds values that are at least 100,000. So if we run this, it says, all right, all of the elements from 260 onwards contain values that are bigger than 100,000. And so the very first one of those, well, we can ask for the minimum of this vector. So month 260 is the very first time that we have over 100,000. And in fact, we see it is just slightly over 100,000. 260 months, how many years is that? Oh, about 21 years. That's kind of a lot. All right, but once we get to large amounts, things start to accrue pretty quickly. How many years does it take for this investment strategy to accrue $1 million? Well, same sort of question here. We're going to ask where the very first element is that contains a value that's bigger than 1,000,000. 1 times 10 to the 6th. And so we see that that's month 376. So 376 divided by 12, well, that's only 31 years. That's a lot of time, but hey, this is a pretty simple investment strategy. Open up a bank account with $100. Make sure that bank account's making 2% interest, which is pretty generous in this day and age. You might not be able to find something like that. But if you deposit just $10 a month, in 30 years, you're going to be an automatic millionaire. So pretty interesting. And there we go. That's the activity for this week.